Welcome back! Today, I'll show you how to bring real-world terrain from Google Maps into Rhino, scale it accurately, and trace clean contour lines for architectural site modeling, like this. Finally, I'll demonstrate how to turn those contour lines into a fully navigable 3D terrain model inside Rhino. This is the workflow I use when building site models from real locations. Let's start in Google Maps. First, open Google Maps and navigate to your project site. Here, I've randomly selected the Polvadera Mountain in New Mexico with clearly visible terrain contours, but you can search for any location using the search bar. Next, enable the terrain by clicking the Terrain option in the lower left corner. Now zoom in until you can clearly see the elevation markers and contour lines. Now, be careful not to zoom in too far. If you do, the elevation labels will disappear. If that happens, simply zoom back out with your scroll wheel on your mouse until they reappear. Once your site looks good, use your snipping tool to capture the screen. Make sure your screenshot includes the map scale, since we'll use that to accurately size the image in Rhino. Now, let's move into Rhino. First, select your model template. In this case, I'll select Large Objects, Feet. To insert the image, type Picture in the command bar and press Enter. Locate your saved screenshot and click Open. In the top viewport, left-click once to place the first corner of the image, then click again to place the opposite corner. Next, double-click the top viewport title to maximize it and zoom into the scale shown on the image. We'll now resize the image using the captured scale. Start by drawing a line directly over the scale bar. In the command bar, type Line, then press Enter. And make sure that ortho is turned on in the status bar. I can also see that my cursor is snapping to grid points, so in my case, I will also turn off grid snap in the status bar. Click the left end of the scale for your starting point, then click the right end of the scale. Press Escape or right-click to finish the command. Now, use a crossing selection. Drag from right to left to select both the image and the line. Type Scale in the command bar and press Enter. For the base point, click the left endpoint of the line. For the first reference point, click on the right endpoint. For the second reference point, type the real-world distance shown on your scale, in this case, 500, and press Enter. Now, your image is scaled accurately. To confirm the length of the line, type Length in the command bar and press Enter. Then, select the line. The command line should report 500 feet, confirming the image is correctly scaled. First, create a boundary representing the project extents. In this example, I'll draw a rectangle measuring 7,000 by 4,000 feet to establish the overall site area. Next, lock the reference image so it doesn't accidentally shift out of place while tracing. Select the image, type Lock in the command bar, and press Enter. With the image secured in place, you can now begin tracing directly over the map using Rhino's drawing tools. For example, use InterpCrv to trace contour lines. Before we begin tracing, make sure ortho is turned off in the status bar. Otherwise, it can override the InterpCrv command and prevent smooth contour tracing. Continue tracing until your site geometry is complete and ready for modeling. And that's it. Your Google terrain map is now properly scaled and ready for site modeling in Rhino. To continue, I'll demonstrate how to turn these contour lines into a fully navigable 3D terrain model inside Rhino. First, you need to manually change the elevation of each contour line. As we can see from the reference image, there are 40 feet between each contour line. So, we will raise each contour line with a constant interval of 40 feet. A faster way to do this can be to use the Gumball widget. First, turn the Gumball widget on in the status bar. Then, select the first contour line. With the line selected, click on the blue arrow in the Gumball, then enter the contour interval, in this case, 40 feet. Next, we'll raise the remaining contour lines in regular elevation increments. 80, 120, 160, and so on. You can raise any remaining contour lines using the Move command. Select the contour line, then type Move in the command bar and press Enter. In the command options, click Vertical. For point to move from, select an Osnap on the curve. For point to move to, select an Osnap on a nearby contour line. Then, use the Gumball widget to raise the contour line to the remaining required height. And you can repeat this process as necessary. Next, you can return to your default 4 viewports by double-clicking on the viewport title, then zooming out and centering your drawing in all of your viewports to check for accuracy. When working with contour curves in Rhino, a lot of people try to create a terrain surface directly from the curves. In practice, that approach usually produces distorted or unreliable surfaces. The most consistent method is to convert the contours into evenly distributed elevation points, and then generate the terrain surface from those points. Here is the workflow. Begin with a set of contour lines that already have the correct Z elevation values. Each contour represents a constant elevation, so Rhino already understands the vertical height information. However, the curves themselves are not ideal inputs for surface generation. Instead of trying to patch the curves directly, we will first convert the contour curves into a set of elevation points. Select all contour curves and run the command divide. Then press enter. In this case, for drag seam point to adjust, I'll simply press enter. In the command bar, switch the mode to length. Then enter a spacing value. For this site, I am using a spacing of 100 feet, which produces a good distribution of points across the terrain. Rhino will now place points at regular intervals along each contour line, creating a consistent point distribution across both long and short curves. The result is a balanced set of elevation points distributed across the entire site. This step is important because the patch command works more reliably when it fits a surface to points rather than long stacked curves. With all of the points still selected, run patch. In the Patch Surface Options dialog box, set sample point to 20, surface U spans to 100, surface V spans to 100, stiffness to 1, check Adjust Tangency, Adjust Trim, and Delete Input, and click OK. Because the points are evenly distributed across the terrain, the resulting surface is usually much cleaner and more stable than attempting to patch the contour curves directly. If you take a closer look in your perspective viewport, you should now see the terrain passing directly through the contours and the points. Next, select your site boundary on the construction plane and run the Extrude Curve command. In this case, make sure the extrusion is set to solid equals no and both sides equals yes in the command bar. Drag your mouse up and left click when the extruded surfaces have completely intersected the previously created patched surface. Next, trim away the excess geometry by running the trim command. For cutting objects, select the extruded surfaces, then press enter. For objects to trim, select the excess portion of the patched surface to remove the difference. Right-click to run the trim command once more. For cutting objects, select the planar surface on the construction plane. For object to trim, click on the excess portion of the extruded surface in the negative z-axis. Next, unlock the original reference image by running the unlock command. Then, select the image and run the hide command. Lastly, create a surface from 3 or 4 points on the construction plane, using the endpoints of the extruded surface as your Osnaps. To finish cleaning up your model, run the trim command once more. In the command bar, type trim and press enter. For cutting objects, select the patched surface and press enter. For object to trim, select the excess geometry of the extruded surfaces in the positive z-axis, then press enter. And that's it. Your terrain model is complete and ready for site modeling or further development in Rhino. In closing, to turn the points off in the perspective viewport, click on the pull-down menu in the viewport title and select Display Options. Scroll down on the right-hand side and deselect Show Points. Then click OK. If this helped you, don't forget to subscribe. It really helps support the channel. Thanks for watching, and I'll see you in the next tutorial.